I have an excellent, exciting announcement today, so I am looking forward to seeing folks online. I can share this news with them. Yeah, and a lot of people have asked me about GraphQL and Janaga. And as it, what I usually answer is that GraphQL is all about selecting the current state of the graph, and Janaga is about achieving eventual consistency, so they don't really solve the same problem. And so when people ask me, hey, can you just use GraphQL as the Janaga API? I say, no, that doesn't really fit. But I just accidentally did. It's not exactly GraphQL. It's not the GraphQL specification, but I was really close to a way of selecting the current state. And so I made it work. So I'm going to be showing off what we can do with that query language, selecting the current state from the server. This does not preclude a client from achieving eventual consistency. Clients should not use this API. It's not intended for clients. Good afternoon, Jan.
Michael, good morning.
How do you do, sir?
I'm doing fine.
Hey, Caden, how's it
Hayden.
going?
Hey.
Good to see you, sir. Well, we've got some exciting stuff happening today. I was working on fixing some bugs this past week and realized that we're really close to being able to project the current state from the server as a way of kind of giving you that SSMS experience. As you're developing an application and you create a bunch of facts on the server, it's really hard to write a query just on the fly ad hoc in order to see what's there. And so I took a slight detour and made that work. So I've got some fun stuff to show.
So that's the SQL Management Studio experience.
Yes, exactly.
Okay.
Yeah. So as a developer, you can actually just inspect your database, which is very hard to do before without actually writing code.
Michael, before you show me that amazing stuff, can you help me out with some simple stuff here?
Yes, indeed.
Yeah, I was trying to wait. Let me get my window a little bit smaller. Yeah. Wait. Share that screen. I even don't succeed in saving facts anymore. So the purpose was just to save a few facts and then run the specification across these facts. So what I did is import the Janaga server. I import my type classes here. So far, so good. Yeah, this one I don't need anymore, but it doesn't matter. I adapted my connection string, and then I said, okay, I need my J here, which I get from JanagaServer.create. And there it complains. So if I run this, it tells me cannot read properties of undefined. So for one or the other reason,
okay,
Janaga server is considered as undefined.
Okay, so let's go back up to the import again and see what's going on. Okay, so Janaga. So that's, yeah, interesting. Yeah, that should be the. Okay. I think I know. There are two. There are two files in the distribution that represent endpoints. The other one is index. So actually, if you just get rid of the /janaga and you just do /dist, it will use index instead.
Get rid of the /janaga.
Yes. Yeah.
Then what is he gonna find here?
So go ahead and open up the file browser and take a look in dist, and you'll see a whole bunch of files. But Janaga.js is the client-side entry point. Index.js is the server-side entry point.
This one.
Yes. So that you can see define Janaga server in there. So yeah, we could have said /index, but that's assumed. So
yeah, that's that one. Okay.
Yeah.
So where was I here? So just to make it clear.
Okay.
Yeah, that's one of the main pain point of Node.js.
Mm-hmm. Okay, we are at a different.
Yeah, now we are somewhere else.
Okay, so we've got a validation.
Specify the type of the facts and all it predicts.
Okay, so I wonder which one it's complaining about. Yeah, so you're inside the compiled version of Janaga, because apparently the type or the what do they call that map? Mapping the source map. That's it. Yeah, the source map isn't working apparently, but the problem is actually the first time that it's in your code. So if you look down further in the stack trace, then we should see the first time that it's here. Yeah. So that one is just raw. Oh well, that's not very helpful. Oh, okay. The next one up. So inside of run. There we go. So, all right. So it's validating and finding something wrong with those, but it's all using the model.
Is it null here in JavaScript?
It is, yes.
Okay.
And that should be good. It should allow nulls. Okay. Wait a minute. That last parameter is actually an array, not a single fact. So make that an empty array there, and then in the next line, make it an array containing just username Jan.
How do we make an empty array in just JavaScript?
Yeah, just open close square brackets. Yeah.
Square brackets. Like this.
Yep. And then on the next one, you can put square brackets around that one object.
And I keep struggling with all this stuff.
Mm-hmm.
And so now,
okay.
Normally, when I save something, it should automatically restart. No.
It's only watching specification.txt.
Oh, okay. That's why.
So with this one, you have to
cancel,
kill it, and then run it again.
Yeah.
Oh, still having a problem. Okay.
I'm not happy about it.
Is it still the same error that it says please specify the type?
Yeah.
Yeah.
The fact that all its predecessors before here there were more.
Oh, okay. I think I see the problem. So let's take a look at the username constructor. And I think it's that it just has one. Oh no, you've got first name and last name. Okay.
Yeah.
Okay. So
user first name, last name, prior.
Okay, so this is a different username than I was expecting. Okay.
Wait, if you would just
Okay.
cancel this one out.
Yeah.
And see what it does then.
Yeah. So supplier's good.
So
yeah.
So this one is good. This one is good. And then here we.
Yeah. So let's double check those two constructors, username and worker.
So we had worker and supplier. Worker takes in a supplier and a user. Type supplier and the user. And which one else was there? And supplier, he agreed, eh? Supplier.
Yeah. So let's see if there's something different about supplier. And no, it's doing the same pattern. Yeah. That is really strange. So yeah, it should create that prototype, and now we're talking JavaScript prototype, and then attach the string to the type field of that prototype, and then when you say supplier.type, it gets that string, and so you do that after you've made it through all of this, and so it should be populated even though it's declared in the opposite order. And so the other difference is the predecessors. So supplier has no predecessors, user has no predecessors, but username and worker both do.
Yeah.
So okay. Maybe you've got the promise and not the actual fact. So let's take a look here. Yep. Put await in front of those, and that'll do it. This is why I love programming in TypeScript rather than JavaScript. But for this, I was like, this is just a quick throwaway thing. I don't want to set up the TypeScript compiler and all that stuff. Yeah, maybe that would have made things easier.
Okay. Where is my... How can I get it here now?
It should be Control tilde. Brings up back the terminal.
Control tilde, but I don't have a tilde on my keyboard. Belgium keyboard.
Huh?
I think it's Alt 126 if you want to.
So yeah, this is easier. Oh, it said Alt G. Interesting. Okay. Okay, so we got something. Oh, wait, no. Okay, it was starting up.
No, here it starts. So yeah, it's working. So that should be okay. So now, if I stop this. And
okay. Yeah, you just populated the data. Okay. Yeah, now you're going to run the query. Got it.
I just took all this out
to
make it easier.
Okay, undefined reading close. So now it is trying to perhaps close the database connection, or close the, yeah, let's Postgres store.
I use
Okay.
the close on Postgres store. I'm not using this close.
Right.
Because I assigned here.
Mm-hmm. Okay. I suspect that, yeah, so cannot read property of undefined. And so Postgres store is coming back as undefined. Let's see.
There is another one there. PG store.
Okay, well, j.postgres store, well, I'm not even sure why that would be exposed. Yeah, it shouldn't be on the J object, because J encapsulates a graph of providers, and so there's like your storage provider, and then inside of there it knows that it's Postgres, and so it's got the
What I can do is here.
Yeah, let's create a new one and just point it at the same database.
Or with my connection string.
Yeah.
Like this. Save this.
Okay. Well, this is progress. This is good. This is actually one of the bugs that I fixed.
Yeah.
So.
Because he's telling me here unknown input type, of course, because I'm still using this one.
Yeah. So now you can write a specification that is about your model.
Yeah. Okay. So now this is working. the rest, let me suffer. Let me suffer. I'll have a look at it. Now we go to, wait, how do I stop this one? Stop streaming. Yeah. And now I want to see our progress.
All right. That was fun.
Yeah. There's always a reason why it doesn't work.
Mm-hmm. Yep. But yeah, honestly, the reason that I love going through that stuff is that I know that that we can make the first time developer experience better, and so every time somebody that's got more experience, like we've been working on this for a while now, runs into a problem, it's just like, okay, there's an opportunity for us to fix things, and so as a first timer, you should be able to come in and just say, oh, I want to try out this this model, this thing, and so yeah, the whole idea of like we discussed last week of creating a Docker image that has the example already running in it, that would be helpful.
Yeah.
All right. So what I added. So we've been doing the npm run interactive. I now have npm run interactive results. So let me get this down to just a bare bones, simple specification, and let's take a look at results. So if we just run interactive, what we get back are the our different feeds. Each one is bookmarked and has different fact hashes that or fact references that go along with it. The intent being that the client is going to continue to call back, walking those bookmarks until it gets all of the information that it needs. And as it's doing so, it's going to call the load endpoint in order to load any of the facts that it doesn't yet have, and that gets its database up to date. So looking at a bunch of hashes is not very helpful for understanding your model. But if we've got an endpoint that takes this and then gives you back results, then this does help you with understanding your model. So what we've done so far here is starting from the semester, the user right now is not used in the specification, so it's just ignored. And then we're getting all of the catalogs in that semester. And then, since we're looking for the results, what we're going to show are the oh, wait a minute, I have to save it. There we go. There we go. That's better. Since we're looking at the results, all we see are the facts that are in that tuple. So here is the catalog of Dallas. So if I were to say, let's go to Chicago and create a new course, then I can say, getting in the Windy City. Okay, so we've got, is that kiting, kiting? I don't know. Let's pretend that it's spelled that way. I actually don't know. But, so we've got a fact now that's in the Chicago catalog, and so if I hit save to run it again, now I'm getting two catalogs back, Dallas and Chicago. And so, if I were to actually give you the whole fact, then in addition to Office, you would see type is improvingyou.catalog, as it says up here, and it would also say that underscore in is this whole object that is the Improving You semester, and then all of its fields, and then its predecessors, and you would get this whole transitive closure of everything that's inside of the catalog. But all of that stuff is not useful as a user to understand your model. So so all it does is shows you the fields of the facts in the tuple. And so those things are quite useful. Now, excuse me. If you did want to see like a field of a predecessor, then you would just have to include that in the tuple. So do all your joins up here, and then you can see all of the fields in all of those facts. But this might be a little bit too verbose for what you're trying to accomplish. So what you can do now inside of your projection is you can say, let's give one of those things a name. So I'll say catalog.office. I will now just name that office, and so now I'm just getting back the office property, and it's just pulling it from the catalog fact. And now I'm inside of a projection, so I can continue. Let me do the courses, and that is now a collection of course, improving you course, such that course in improving you catalog equals catalog. And so now I get, for each office, I get a collection of courses in that office. So in Dallas, we've got these 1, 2, 3, 4, 5 courses. Kind of hard to count when the scroll is working like that, but here's 3 and there's 2, so we've got 5. So if I take a look back at Dallas, I'm only seeing 4. Why is that? Oh, that's because I needed to specify where not exists, delete being an improving you course delete, such that delete course improving you course is equal to this course. So hopefully that was the right thing. So now we've got 1, 2, 3, and 4. So we only have the 4 that are not deleted. Yep. So course created at, not very interesting. So let's go ahead and for each one of these, let's project. And we want to get the course titles. So titles is not a field of the course. It's a successor. It's a property. So so we do a nested query there. So I'm going to do title being an improving you course title, such that title course, the improving you course, is equal to course. And now we've got all of the titles. But you can see I've got all of the versions of all of the titles. So that's not quite what we want. We also want where not exists the next improving you course title, such that next prior improving you course title is equal to title. So yeah, equal to
is misspelled. ENR.
Thank you very much. All right.
So how do we know that is prior?
That is all built into the model. So
Okay.
yeah, let me see if I've got the improving you model handy. I'll just open that up. Here's the improving you course library. And so this is part of the shared, because both the client and the server are interested in the model. And we've got the here is the course portion of the model. So yeah, there's course title, improving you course title, and it's got the course, it's got the value
prior.
and prior is a collection of prior course titles that we're replacing.
Okay.
Yep, so that implements the mutable property pattern, and it says, well, if the one that you're looking at right here is in the prior collection of some other course title, then drop it. So that way we only get the leaves of the tree. So the equals operator, just like in, well, no, it's actually different in the, yeah, when you're coding against the model, then the language in which you're coding knows that it's a collection, and so you use contains operators inside of JavaScript and C++ or C#. But yeah, here it's just normalized. It doesn't matter if it's a single valued or a multi-valued. It's just we're going to use the equal operator to see if it's in a collection. All right, so the last little bit here to clean up is that we've got now for these titles that are coming back, we've got this object title with the value. We can make that a little bit clearer just by saying title equals title dot value, and so now it's got that title's object. And so this is getting pretty close to what you would expect as a user just kind of navigating through your data. This is, give me a snapshot of the current state of the system. there's not enough information in here to be eventually consistent. But I think what we can do is offer this as an endpoint. So when you publish your Janaga application, you can hit this endpoint using Postman or whatever tool you like, and then run these queries and then see the results. Yep.
But that's only possible if you know that specification language.
That is true, yes. So kind of a next level developer tool would be something that knows your model and gives you IntelliSense on this. So I know that there are instructors for courses, and so an instructor is an improving you course instructor. And then the instructor course is improving you course, and there does not exist. Well, there's the tilde key. A next improving you course instructor, such that next prior improving you course instructor is equal to instructor, and then I can project the instructor.value. And now I should get, there we go. Now I can just see that that information it attached to the object that it's supposed to be attached to.
Mm-hmm.
Yeah, one thing that I'm thinking might be helpful to like in these cases, I haven't made this work yet, but it might be helpful to just do that. So now here you would get just instructors as an array containing just the string Michael, and you don't get this extra object. I think that would be useful, so I might go ahead and make that work. Let me see what what error it gives me when I try this right now. Yeah, specification parser. Yeah, that's not a valid projection. It's looking for open bracket. Cool. So yeah, if we had a an IDE that understood your model, then it could give you IntelliSense, and you could, like here when you hit dot, it would know, okay, instructor is in this tuple up here, and it knows that's an improving you instructor, and so it would know your model, and it would know that here you could say, dot value. That's the only field in that fact. These other two are predecessors. So it would not list predecessors here because this is just projecting fields, but it would list predecessors after the arrow. So yeah, using a different syntax to indicate I want to walk along an edge, the arrow, versus I just want to access a field, the dot. But yeah, that IntelliSense would help in all of these places. So not just recognizing the fields that are already here, but recognize the inputs, recognize the parts of the tuple, the information that comes from the model. So that is a bit more of a a challenge. Somehow you have to get your model into that IDE. So maybe there's an endpoint by which the server exposes its model, and then the IDE can load that in. Don't know. Seems like it'd be useful.
I've heard that language server protocol would be more easily to integrate than the intelligence sense.
Yeah, so that way Visual Studio Code and Visual Studio could just could use those language specifications.
Yeah, then because since language server protocol is open standard, so I think you just follow the let me look up language server protocol. Yeah. You just follow the protocol to define how your language looks like, and I think that's easier. I don't know because I haven't used it yet.
Okay, yeah.
And most of the text editor and IDE supports this.
Nice. Yeah. Yeah, so then, I would implement a language server inside of, and so this actually is this is telling me I might want to have a separate server. So here's the language server for Janaga, and it is exposing the model so that you can do the autocomplete. Go to definition, find all references. Would that make sense in this case? Since you don't have, no, maybe, yeah. If it compiled a source map from your JavaScript or your .NET code into the generated model, then you could actually say, hey, go to the source for that particular field, and now you're looking at the .NET record, or you're looking at the JavaScript class declaration. Yeah, that'd be kind of cool. And then yeah, you could just use that language server in Visual Studio Code as you're writing the code for your application. You're just accessing JavaScript or .NET code, but then you say, I want to point to my running server, and so you've got the server that is the Janaga server that's serving up the data, and it's providing this capability here, and you've got the language server that is using the model, giving you the IntelliSense, and so that's pointed at your source code, not at the raw data. And so now the IDE is using that one for IntelliSense and for navigating, to the source, and then when you run the model, then it goes to your running server and gives you back your data. Yeah, I like that idea.
Yeah.
That is cool. Oh, I thought I had a Janaga folder in here. Oh, yeah, that's the one. Okay, cool.
And I have another question. That if we find some facts are irrelevant, do we have any mechanism to minimize the historical model?
The mechanism that I like to use is to stand up a new instance and then pull all the information that is relevant through that new instance, and so you can kind of roll these instances back in time. So you could even make it part of your routine, like every 6 months you have some automated process that takes your current instance, makes that the backup. The new one is completely empty, and it's pointing at that one as as its upstream. And then as users use the application, it pulls the data that the users are actually using into the new one.
Okay, looks. Yeah.
Yeah, and the way that that all works. Right here on the Janaga server, when I set up the when I set up the create the Janaga server, in addition to pointing at the database and having your authorization rules, you can say, and I want it's not giving me IntelliSense here for some reason. But yeah, what you do is the endpoint. And so you would say, that's an endpoint of some other running instance of Janaga.
Okay.
And that's it. And then it says, okay, let me look for information to satisfy that query locally, and finding none, then, or even if it does find some, it then goes to that endpoint and says, here, run this query for me, and load it up, stores it locally, and returns the result. Yeah, so right now that endpoint is not terribly intelligent in that right now it doesn't have bookmarks because the Janaga query endpoint doesn't have the bookmarking capability that we just added. But and so that means it's going to run the query. It's going to get back all of the facts and say, oh, I've already got most of these. Or in fact, if that has now gone stale, it's like, oh, I've got all of these. So I don't care. But yeah, once we publish this new specification language and have it used for client-server and server-to-server communication, then this one will just maintain a list of bookmarks for that particular server, and it'll say, oh, I already ran this query against you. Anything new? No? Okay. Yeah, I like this idea of separating the model from the infrastructure. The topology of how things are connected. So it's the same model. You just and when you're coding against the model, all you care about are I want these facts and I want these relationships. But then when you deploy, you've got some setup code that's now setting up your infrastructure, and it says, let's go ahead and connect things in this way, create these particular shapes.
Yeah, so maybe we can have several teams working on different models, and we can roll it out step by step.
Yes, yes, indeed.
Yeah.
Yep. That's the that's one of the things that makes professional software development difficult right now, is that you have dependencies among teams. So enterprise development gets really slow, and people have come up with procedural ways of solving that. Trying to scale agile, so safe and less and scaled agile framework. Well, that's safe. Okay. Anyway, so they've come up with processes for managing those dependencies among the teams. But if it's not part of the way that you design your architecture in the first place, then that only gets you so far. But here it's like, and do those things, and you've got an architecture that doesn't break when your dependencies change. It still upholds the eventual consistency.
I'm thinking like microservices that each team works on individual features, and they can deploy that individual features independently.
Yes. Yeah, that is what this will ultimately enable. So rather than just a single endpoint, you can have a collection of endpoints. So these would be the different microservices that you've set up. They would really just be the different repositories that back those microservices. So I'm interested in interacting with sales. So yeah, one of my endpoints is going to be the sales Janaga instance. But then so this will become something like this, and that way you can say, and another endpoint is going to be my inventory or my logistics endpoint. And so then people who are using just those systems are only pointing at those servers, and so the facts that they generate go into those servers. But then when I've got a client that depends upon those, I just include those in my set of endpoints, and now I've set up the topology for the information to flow through. The next step is to then express interest at the level of the model. And so when I end up writing code that generates a query like this expresses interest. And it says, okay, I'm looking at feeds, looking for these types, and so then the runtime says, let me go and talk to all my endpoints and express interest over there. And so when I express interest to sales for fact types that are about logistics, then it says, I don't know, nothing. Likewise, I go to logistics, I ask for sales, nothing. But they each will contribute the parts that they know. And then because I, on the receiving side, have joined them together, probably with a fact type that only I know about that has both of those as predecessors, then I get the full graph just here.
Yeah, that makes sense.
Yeah, which brings me to one other defect that I fixed. Before, in order for me to write this not exist query, I had to have actually gone in and deleted a course. And that will add the improving you course delete type to the database. And then it can say, oh, I understand that type. But if I hadn't done that, then like if I had some new type that it had never seen before, then it would have thrown an exception saying I can't find this type. But now, when I run it, it runs just fine. I still see the deleted courses because now I'm not looking for the delete fact. But the way that I solve that is if you're looking for a type and it shows up in the main line, so like you're looking for this type and you can't find it, then there's nothing that could possibly satisfy this part of the specification. So courses comes back as empty. Okay, well, so I've got a bug in there for that. But let's suppose that it was up here. Nope, same bug. All right. Okay, so I've got a little bit of work to do there. But the idea is that it'll come back empty. Oh, it's right here that that I made that work. No? Interesting. That should have... Well, all right. Well, definitely some work to do there. But yeah, if it finds a type here that doesn't understand, then catalog is unsatisfiable. If the catalog type itself is something it can't understand, then catalog is unsatisfiable. And that means that the entire tuple is unsatisfiable, because every part of the tuple, all the conditions have to be simultaneously satisfied. And so that gives you back an empty collection, or should. And if you have an unknown type inside of an existential, specifically a negative existential condition, then it knows that this is unsatisfiable, therefore the negative existential is always true. It's not falsifiable. And so we just drop that condition, and it's like as if we had never express that condition because it can't possibly be true, or it can't possibly be false. Sorry. And so that's really the more common scenario is you're building up your model, but people haven't used it enough in order to create facts of all types within your model. But it should still work. It should still give you back all of the courses because no courses have been deleted yet. And so just don't even include that where clause.
Mm-hmm.
So that will help in developing a model. That'll also help in interacting with other teams, because now you are depending upon their models, and as their model progresses, you're going to have new facts, new fact types that you don't yet have instances of, and should just work just fine. Yeah, so I'm pretty happy with this.
That looks promising to play with.
Yes, indeed.
Michael, you spoke just now about facts that would not be known to others at a certain moment. And so you could combine data from multiple servers.
Mm-hmm.
Would that be a kind of security feature then?
Yes.
Or
yes, indeed. So actually, I was just looking this up this morning. So there are two security features that I talk about here. Only one of them right now is implemented in Janaga. But there are authorization rules, and then there are distribution rules. And since I had never actually implemented distribution rules in Janaga, I was like, man, how did I write about those? And so a distribution rule says for this particular query, who's allowed to express this query, who's allowed to ask for this information. And then you use the starting points of that query to navigate back to a set of users. And so now if the logged in user is one of them, then they're allowed to see that information. The challenging part is now when you're talking server to server, a server doesn't represent one user. A server is making this request on behalf of originally a user, but maybe they want to establish this feed and then keep it going. So there's still some kinks to work out with the server-server communication. It might be that at the time that you establish it, you prove that you are doing so on behalf of a user. Not sure if I like that solution. But yeah.
Because that would mean that the server must be trusted, because he could just cache the data for the next user.
Right. Yeah. Exactly.
Unless it is encrypted.
Yes. That is the. Actually, I guess that's the third security. That one is true security. Distribution lists are a second level, a weaker level of security, where if you found a way around the distribution list restriction, like you said, use one user's credentials to get all of the data, but then make it available to all users. Then you would still want to rely upon that first level, and that is encryption. So for that, you'll want to generate shared keys and make them part of the model, and then you encrypt the shared key for a particular user. So I invite you to join me on this repository. So here's this GitHub repository, and I've got issues and pull requests and everything. And so, okay, I'm inviting you to see this information. If I'm inviting you to actually take action, then I have an authorization rule, and then for you to express that fact of accept pull requests. Well, who can accept pull requests? People who have been invited as contributors to this repository, can accept pull requests. But then there's a different invitation that's inviting you to see this repository, so you can see all the issues and pull requests, but you can't. You're not authorized to create anything. And so for that, you'll want that invitation to contain an encrypted shared key, encrypted using that user's public key. So now only they, with their private key, can actually decrypt that shared key.
Oh, yeah.
And then they can use that shared key to decrypt all of the facts. So yeah, that's something that that also needs to be built into the underlying infrastructure, so that you can express in your model just a type. This is my shared key type, and then it knows what to do with that. And then when you express a fact, you say all the fields of this fact are encrypted using the shared key, which you can obtain by walking the graph in this way. It all ties back to walking the graph.
Mm-hmm.
All right, so that's what I got for this week. I think for next week, I want to return to the direct route of making Janaga.net work against a server. So Jan, you're still working on the database access, and so are you going to be investigating more the execution of these specifications?
Mm-hmm. That's correct.
Excellent. So
Yeah.
Mm-hmm.
I'll keep reading through to the chapter 7, which is the security part we just discussed.
Yes.
Yeah, I haven't read to chapter 7 yet.
Okay, cool. Yes.
Hopefully I will finish it. Hopefully.
Yeah, excellent. Yeah, and then we can further discuss how to express these rules when we're talking in JavaScript or in .NET, and then how does the underlying infrastructure implement these rules. So we've got authorization rules in Janaga.js, but have to do the encryption, have to do the distribution. And I will take the two interactive modes that we've got so far and expose them through API endpoints. So there will be one that the client can hit in order to get some feeds, and then there'll be another one that a developer can hit to walk the database. And then ultimately, when we get distribution rules in, those will be applied to both of those endpoints, so that you wouldn't be too concerned about publishing out to the internet an endpoint that lets somebody query your database, because you'll have the distribution rules in place to say, well, I'm only going to give them back the information that they're allowed to see anyway. But not working on distribution rules this week. Maybe next week.
Okay, I'll keep reading.
But what would be the difference between these API endpoints for developers and for users?
So a user would be using a client-side application that's hitting the feed endpoint. So the client is going to cache the facts that it receives from the feed. Could be a persistent cache, could be just a memory cache.
For the user, it's just an interface with the application. For the developer, it's the specification that you write out, just like we did just now.
Yes.
Okay. Yeah.
Yep. Very good. Well, I think we have a plan for the week.
Yeah.
Awesome.
Yeah. I'm going to try to get this, this specification working.
Mm-hmm.
Yeah, with some that will help to make me understand how the specification language really works.
Yes. Yeah, and I haven't yet done the comparison between where the specification data structure ended up and the specification that's in Janaga.net that is basically the data structure that represents your link specification. I suspect that they are mostly quite similar, but I don't yet know where the differences are, and so that's going to be part of what you'll be doing in order to interpret the .NET specification or convert it into a different data structure, whichever one works out to be the right choice. But then, yeah, ultimately we can take that .NET data structure, maybe convert it, but certainly then turn that into text, and we can generate the specification language that we just wrote. And that'll be how we call the API endpoint.
Yeah, there is still some work to be done.
Yeah.
But it looks promising.
Excellent. Well then, I will see you all back here next week.
Next week, Thursday. Okay.
Excellent.
Okay, then, Michael, see you next week.
Bye bye.
Thank you, Jan. Thank you,
Bye.
Caden.